In the last two modules, we have introduced the ideas of equilibrium and reaction rates. These are not separate topics. Rather, the equilibrium constant, big K, and the little k's, the forward and reverse rate constants, are related to one another. Let's think about a process where coins can flip back and forth between heads and tails. We could write this reversible process like this. We could also write rate laws for the forward and reverse processes. The rate of the forward process is K sub F times the concentration of heads. The rate of the reverse process is K sub R times the concentration of tails. But what if we knew the values of the rate constants? What if K for the forward process was 1/2 per minute, and K for the reverse process were 1/4 per minute? And what if we were to start with 24 heads and 0 tails? How would the process proceed? In this demonstration, we're going to be flipping coins between heads and tails. Now, heads and tails are a little bit hard to see on real coins on this camera, so instead I've got a piece of paper with the penny head on the front, and on the back is blank, so it makes it easier to tell a head from a tail. And this is not a normal probability experiment. Rather, we've got this reversible process, head going back and forth to tail. The rate constant of the forward process is 1/2 per minute, while the rate constant of the reverse process is 1/4 per minute. And we'll see what that means as we go along. So at the start, we'll keep track at 0 minutes. We have actually 24 heads and no tails. And what the rate constants tell us is in the first minute of the process, half of the heads will flip and 1/4 of the tails will flip. Now, there are 24 heads, so half of them, or 12, will flip. There aren't any tails, so we can't flip the other way yet. So I'm going to flip 12 of the heads. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now, after 1 minute, we have 12 heads and 12 tails. So the next minute, half of the remaining heads will flip. Now half of 12 is 6, so 6 heads will flip, and 1/4 of the tails will flip. Well, if there are 12 tails, 1/4 of that would be 3 of them. So let's flip 6 heads. 1, 2, 3, 4, 5, 6, and we'll flip 3 tails. 1, 2, 3. So now, after 2 minutes of the process, how many heads do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got 9 heads and 15 tails. Notice they always add up to 24 because we have 24 coins. Now, in the third minute, we're going to flip half of the remaining heads. If there are 9 heads, well, we should be flipping 4 1/2, but we're going to round up. So we're going to round up to 5. And we're going to flip 1/4 of the tails. If there are 15 tails, 1/4 of 15 would be 3 3/4, but we're going to round up. So we're going to flip 4 tails. So let's see how this works. We're going to flip 5 heads. 1, 2, 3, 4, 5 heads, and we're going to flip 4 tails. 1, 2, 3, 4. Now what do we have? After 3 minutes of the process, we have 8 heads and 16 tails. Now in the next minute, we're going to flip half the heads. How many will that be? Half of 8 is 4. We're going to flip 1/4 of the tails. How many would that be? Well, 1/4 of 16 is also 4. So if we flip 4 heads, 1, 2, 3, 4, and we flip 4 tails, 1, 2, 3, 4, and again, after 4 minutes, I've flipped, or I have, a total of 8 heads and 16 tails. Next minute, 4 heads will flip, 4 tails will flip, I'll still have 8 and 16. So in this case, I've reached equilibrium. The process reached what we called a dynamic equilibrium. We could have continued on, flipping 4 heads and 4 tails every minute, but the head-to-tail ratio would not have changed anymore. We see at equilibrium that there are 8 heads and 16 tails. We could compute the equilibrium constant, big K, which gives the product-to-reactant ratio at equilibrium. In this case, that would be 16 over 8, which is 2. Using the language of equilibrium, we would say that this reaction is extensive since it ends up with more product. We also know about the sign of the standard free energy change, delta G0. Since the reaction is extensive, delta G0 must be negative. We also could have figured that out watching the process. After 1 minute, there were 12 heads and 12 tails. Although it's not clear what standard states may be for coins, that is where there are equal amounts of reactant and product. And at that point, the forward process was still spontaneous. It still went in the forward direction. But let's take this one step further. At equilibrium, we know that the rate of the forward reaction and the rate of the reverse reaction are equal. 4 heads and 4 tails flip every minute. Substituting the rate law expressions, we have K sub F times the concentration of heads equals K sub R times the concentration of tails. Doing some algebra to collect the rate constants on the left and the concentrations on the right, we find this expression. We immediately recognize the right-hand side of this expression as the expression for the equilibrium constant, which we already found as equal to 2. If we evaluate the left-hand side of the equation using the rate constants given, we find 1/2 divided by 1/4, which also equals 2. This shows the relationship between kinetics and equilibrium, between the rate constants and the equilibrium constant.